Earlier in the class, I talked about how things are stored in main storage and how 1 byte has 8 bits inside it. And going from your right to your left, the value of the bits was 1, 2, 4, 8, 16, 32, 64, and 128. What I'd like to do now is sort of explain that a little bit. So here is that one storage location. 1, 2, 4, 8, 16, 32, 64, and 128. And if you recall, capital A was the second bit from the left, the 64, and the 1, last one on the right. So anyway, how do we arrive at those values? Okay, let's talk about the number, if we could, just for a second as an example. 4,132. And we know this to be a base 10 number. What does that mean? Well, let's take a look at going from your right to left. We know that base 10 can use any digit from 0 to 9. And if we have a 4-digit number starting at the far right, that is the value of 10 to the 0, or 1. The next one, the 3, is 10 to the first power, or 10. The next one, the 1, is 10 squared, or 100. The 4 is the place value of 10 cubed, or 1,000. So in other words, going from your right to left, we have 2 1s, we have 3 10s, we have 1 100, and we have 4 1000s. 4,132. What's 10 to the 0 power? 1. What's 10 to the first power? 10s. We have 3 10s. What's 10 squared? 100. We have 1 100. What's 10 cubed? Thousands. We have 4 1000s. Well, take a look at the numbers that are at the bottom of our 8-bit byte. 1, 2, 4, 8, 16, 32, 64, 128. What's 2 to the 0? 1. What's 2 to the first power? 2. What's 2 squared? 4. 2 cubed? 8. 2 to the fourth? 16. 2 to the fifth? 32. 2 to the sixth? 64. 2 to the seventh? 128. So what we use here is a binary, a base 2 numbering system to give us those values. Now, what I'm going to do is give you a very simple practice number. Let's suppose we had the number 1101. 1101. And that was a base 2 number. And you wanted to know what that meant. Well, 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. Here's what it means. This particular 1 over here means 1 1. We have 1 1, and we have 0 2s, we have 1 4, we have 1 8. That value is an 8, a 4, a 12, and a 1, a 13 added together. Let's do a simpler one. Let's just say we have a 0 and a 1. Down at the bottom here, a 0 and a 1. Okay, we have 1, 1, and 0 2s. We have the value 1. Okay, let's do another one. Let's suppose we had 1 0. We have no 1s and 1 2. No 1s and 1 2. Let's suppose we have a 1 0 1. We have 1 1, we have no 2s, and we have 1 4. We have the value 5. Okay? Now, earlier in the class, we talked about capital A being 65. We have 1 64, and we have 1 1, 65. In binary, that would be the equivalent to 0 1 0 0 0 0 0 1. Let's take a look at that. Okay, so if you take a look at that, what we have here is we have 1, 1, no 2s, no 4s, no 8s, no 16s, no 32s. We have 1 64 and no 128s. You take the 64 and the 1 and you add them together and you get 65.